Okay. So for the first one here, this is gonna be a chi-square for independence. And the way we can tell this is by the problem itself. Suppose we take a random sample of 100 girls to determine if there's a relationship between hair color and eye color. So we have two variables, hair color and eye color. So we know that these two variables, since I'm talking about two variables, this is going to either be chi-squared independence or homogeneity. Test using a 10% significance level, so we know alpha is 0.10, whether hair color is related to eye color. So the word related tells us we're going to use a chi-square test for independence. The alternative hypothesis is always that the two variables are related. That's the alternative. The null is always that they're not related, okay, or they have no association, no relationship, or in other words, they're independent. Regardless of what the problem is asking us to do, those will always be the same. So the null hypothesis, we'll go and write this down. Hair color and eye color are independent. In other words, not related. Okay, the alternative, we good there? Okay, alternative hypothesis, hair color and eye color are not independent. We don't want to say dependent, say just are not independent. So they are related. You can just say are related. Now it's up to you. You can use different terminology. You can say hair color and eye color are related instead of just not using the word independent at all. Sometimes students get confused on which one is supposed to be independent and which one's supposed to be not. Just remember that the alternative is always about a relationship. Okay? What comes next? Conditions. Perfect. Our first condition? Random sample. If there's one thing you're going to leave this class knowing, it's that the first condition for any inference procedure is random sample. Right? Okay, so we've got a random sample of 100 girls. These conditions are the same conditions as the goodness of fit. So the goodness of fit one was that the second condition was that the data were in counts, right? So we're going to go and say that the data are in counts. Now, of course, we would like each person to be, each person to be independent, but do we really need to state that in this case, right? We would say eye color, each person in the study, their eye color and their hair color, I guess we'll say are independent of the other person. Although it possibly couldn't be, right, if they're siblings. Anyway, don't worry about that. All right, what's the third condition? Good. Expected values are equal to 5. Now, we can't just leave it at there. We have to have those expected values. So we're going to let the computer do the work. So we're going to do this in Geogebra. So if you have a laptop, a couple of you have it, you can follow along with this. If not, of course, like I said, I've got this recording right here, so I'll post this up to Blackboard as soon as we're done, and then you'll have that recording to do your homework. So I'm going to go to not Blackboard. I'm going to go to Geogebra, geogebra.org. And I'm going to use Geogebra Classic. That's the one I like to use most here. So for this one, we're not going to use a spreadsheet. So thus far, for anything we've done in Geogebra, we did a spreadsheet. This one, we're going to do probability. And notice we have a normal distribution. So if we wanted to do something with a normal distribution, we can. We're going to go to statistics. And on this drop-down menu, we're going to look for chi-squared test. So we do have a chi-squared goodness of fit test if we wanted to do one there, but we're not doing goodness of fit. We're doing chi-squared two-way test. So we're going to do chi-squared test. And then we have to pick the numbers of rows and columns that we have. So we had 2 rows and 2 columns. So this is 2 by 2. And we had brown eyes and blue eyes, just because I like that you can do this. I can label these. You don't have to label it to actually do the computations on here, but I just like to because it tells me what categories I'm using. Okay, then we fill in 1033. $44.13. Okay, there we go. So on the bottom here, you see I have the degrees of freedom. It gives me a chi-squared value, and then it gives me a p-value. We'll get to that in just a second. We don't have our expected counts in here, so we got to click on here where it says expected count, and then right above those are our expected counts. So this right here is what you're going to get on the test. Is you ask what you're going to get on the test. You're going to get this picture right here. Basically, I did this and I cut and pasted it so that you can read this output and tell me what you know about this output. On the lab today, you'll notice on the lab, I believe I already printed out the output as well. Okay? So let's take a look at this and see what it tells us. Oh man, it's not letting me. Delete. Okay, so we'll just go back up there and see what it does. So the next thing we need is our rejection region. Okay, so in order to do our rejection region, we need to have a degrees of freedom. So the degrees of freedom for a chi-squared two-way, put it on the side here. The degrees of freedom for a chi-squared two-way is the number of columns minus 1 times the number of rows minus 1. Hashtag of rows. Yeah, it's number sign for those classic people out there. How many number of columns do I have? 2 columns, 2 rows, and that's going to give me 1. So that's how I got my degrees of freedom 1. Then that was on Geogebra output right here. Okay. But hint, hint, you're going to need to know how to find that. Okay. All right. So my rejection region, I have a chi-squared value with 1 degree of freedom at a 10% significance. Go ahead and look that up on your chi-squared table.
2.706.
2.706, perfect. Okay, what is our chi-squared value according to GeoGebra? Well, let's go back over here and look. Our chi-squared value according to GeoGebra was 28.7057. So knowing that the chi-squared is 28.7057, are we going to reject or fail to reject our null hypothesis? Reject. It's clearly bigger than 2.706. So since the chi-squared value of 8.706 is in the rejection region.
We don't have to solve to get the 728.706. Or is that given?
This right here, you do not have to solve. There's no math involved in this one. Yeah, the most math you have to do for this problem is right here. Okay? So can't do that. A little bit of a problem. We reject the null. There is strong evidence. We use strong because in my GeoGebra output, the p-value here is 0. That's just because chi-squared is so high that it's such a small p-value that it can't report it on the computer. It's probably 0.0000 something. If you're using a TI Inspire or TI 84, it'll actually tell you what that is. But we don't really need that. All we need is the rejection region. So there is strong evidence. What is there strong evidence of? There's strong evidence that this right here, always put the alternative hypothesis in your conclusion. There is strong evidence that hair color and eye color are related, or you can say are not independent for girls. Boom, done. Chi-square test for independence.